All right, today we're going to actually talk about finding max and min values for a quadratic equation. And to do that, we're going to talk about word problems and how to pick that information out of the equation. So at the very top of the page here under the learning target, it says if an object is thrown upward, its approximate height, which is the h in feet, is given by the formula h equals negative 16 t squared plus vt plus c. T is time, and so where we usually have the x value, that's going to be your time here. Where we usually have your y value, that's going to be your height. And v is the initial velocity or the speed of the object, and the c is going to be the initial height of the object. When you guys see this formula, it always has a negative 16 in it, and what that is the force of gravity in feet per second. So negative 16 feet per second is just the force of gravity. That's why you'll always see that in one of these formulas. So here's our first example. It says a firework is shot upward with an initial velocity, so that is v, of 80 feet per second. The firework is on a table 3 feet above the ground when it's fired. So it's not directly on the ground, so it has an initial height of 3, and we're just going to write an equation here. So I'm just going to substitute some numbers in. All right, so this is modeling the height of the firework. Negative 16 is part of the formula, and then we're going to plug in the 80 for the velocity, and the initial height of the object is 3 feet, so that ending number is just going to be 3. Now, if you guys think about this, if you launch a firework, we're just going to sketch like a little picture here. This is not to scale either. So like, let's say that's my 3-foot table, and here's my firework. So no time has passed yet. When we launch the firework, it would go up in the air, and then eventually it has to come back down to the ground because the gravity will bring it back down. So that's all that's going on in that question. Now, after that, we're just going to model some information with the formula that we have and ask some questions about this. So it says, what's the height of the firework after 2 seconds? So that is just going to be the value of the time. That's the t in that formula up there that you see. So after 2 seconds, all you have to do is everywhere you see the t for time, just go ahead and replace that with the number 2 for the number of seconds there. And then totally, if you want to grab your calculator and do this, or you can do it by hand, totally up to you. I'm going to do negative 16 times 2 squared plus 80 times 2. And then just go ahead and add 3. Whoa, whoops, didn't hit the 3. Add 3 for that initial height. All right, so after 2 seconds, the height of the firework would be 99 feet in the air. All right, now to answer parts B and C, I'm going to have you guys kind of look back a little bit at the picture we sketched. Part B says, in how many seconds will the firework reach its maximum height, and then what is the maximum height? So I would tell you, if we're looking at the graph, the maximum height that it would reach is just going to correspond with the vertex. So if you're being asked for a maximum, they're just trying to get you to do the vertex. Now, the way this is laid out, the height, forgive me, time is where we usually position our x-coordinate, and height is where we usually position our y-coordinate. This is a standard form of a quadratic. It's all multiplied out. It's not in vertex form. So what I want to do here, find the time it would take. It would just be the x-coordinate of the vertex, and then find the height that it reaches is going to be the y-coordinate of the vertex. So I'm going to try to keep that equation so you guys can see it real quick for a sec. We're going to use the formula negative b over 2a. So I'm going to write the values down. A is the coefficient of your squared term. B is the coefficient of your linear term or your plain letter. And C is your constant. So I'm going to slide this up. Those numbers came from that equation. All right, so all I got to do for my x-coordinate of the vertex is negative b over 2a. This will give me the time. So for this question, I'm going to do negative 80 divided by 2 times negative 16. Now, it's really important, you cannot just type that in your calculator. It will give you the wrong answer. If you want to do this, either figure out what the bottom of that fraction is first, or put that in parentheses because you need to divide that negative 80 by the product. So you have to do the product in the bottom, the multiplication in the bottom, before you do the division. So if you want to just do it by hand, you could do that too. This will be negative 80 over negative 32. And I know that's not a nice number. The negatives are going to cancel out there. I'm going to get 2.5. Oh, sorry, that's really hard to see on the screen there. It's going to give you 2.5. Now this is the time. Once you have the time to get the height, you just plug that number in. So into my equation, I know you guys can't see this on the screen right now, but I would do negative 16 times 2.5 squared plus 80 times 2.5 and then plus the 3. So everywhere I see an x, I'm going to replace that. And I'm going to see if I can adjust my calculator here real quick before I lay that back up on the screen. Hopefully you guys will be able to see this time. Negative 16, ooh, that still doesn't look good, times 2.5 squared plus 80 times 2.5 and then plus 3. And you guys, I'm really sorry there's a glare there. I'm getting 103. So 103 feet is going to be your maximum height. All right, just another example here. It says the cost in dollars of fuel per week for Bob to operate his truck is given by the formula here. You've got C for the cost, and V is going to represent his velocity here. That's why they're using that, but average driving speed in miles per hour. And sketch a general picture of the shape of this. If you guys look at this equation here, this, even though it's super small, it is a positive number, so this would be a graph that is going to turn in the upward direction. And it says here 142 would be, if I would plug in 0, that's where we would start. So I don't know exactly if this is the best picture to do a graph, but the 142 would be here. The graph would be turning up. Now, in this case, what we're going to do is find some information here in the vertex, but the way I've drawn this graph, we're really not going to be able to see the vertex with our little sketch here. I just want to make you guys aware that if this number in front is going to be positive, that graph is going to turn up, and that's going to cause us to have a minimum, which is what the question is going to ask for. Okay. So the first question says, what will Bob's weekly cost be if his average driving speed is 70 miles an hour? So all this means is we're going to plug in 70 for that V, for that speed in the formula. So into my calculator, and I've tried to adjust the settings on this, so hopefully when I put the calculator back in here, it'll be a little easier to see. But all you're going to do is everywhere you see a V, you're just going to go ahead and replace it with a 70. Oh, guys, I'm really sorry. This calculator is not showing up well today. Let's see if I can adjust it. And it's still not doing well. Okay, so I'm going to try and type this in. Hopefully you guys are doing this on your calculator. And I've got 70 squared and then 0.48 times 70 and then plus 142. You might be able to see it a little bit, maybe not if I move it. No. There we go. Let me see if I can put a little shadow on it. Nope, it's still not working. I'm just going to tell you what it says. Okay, when I hit equals, it gave me a 128, and I apologize you guys can't see that very well on the screen. Alright, there we go. I adjusted some lighting so you guys can see that a little bit. Okay, so 128 is going to be the cost. Okay, now because this graph, and I know this is not the greatest sketch, but because this turns right side up, we would have a minimum for our vertex. So it says find the speed at which Bob should travel to minimize the cost for his fuel. So I'm just going to do that negative b over 2a here. That'll be the speed. And then if you guys think about this, the points here, it's going to be V for the speed, C for the cost. So where we normally position our x coordinate is going to be the velocity or the speed. Where we normally position our y coordinate, that's going to be the cost. So if I plug this in here, And this number is already negative, so I'm going to change this to be positive 0.48 divided by, and then again, put this in parentheses, 2 times that 0.004, and hopefully my calculator is going to let us do this here. So I'm going to do 0.48. You have got to put this in parentheses or it won't work. 2 times 0.004. And I'm going to get 60. So he needs to go 60 miles an hour. And to get that cost, all we're going to do is plug in 60 for V. So 0.004, we're going to plug in 60 for every V that we see in the equation. So I'm going to plug it in right here. 0.48 times 60, and then plus 142. And then I'm just going to throw this again into the calculator to get our cost, minus 0.48 times 60, and then plus 142. So there his costs, $127.60 will be the minimum that he can do. All right, example 3 says a juggler throws the ball into the air from the height of 5 feet with an initial velocity of 16 feet per second. Will the ball ever reach a height of 10 feet? Explain. Okay, so let's try to go ahead and set up our equation first. The force of gravity is going to come into play here, so this equation is the one at the top on the front of the notes. That's where this little formula is coming from. Okay, if he throws the ball into the air at a height of 5 feet when he releases it, that's going to be what we call your initial height, and then your initial velocity here, v, is going to be the 16. So I'm going to do negative 16t squared plus 16t and then plus 5 as the equation of the path of this juggling situation. Okay, now it says, will the ball ever reach a height of 10 feet? Explain. Okay, so what we have to work with here, I would tell you this is negative. This is going to turn upside down. And so the vertex here will be a maximum. So what I would like to do here is find the vertex and see what the maximum height is that the ball will actually reach, and then we can determine whether or not that is bigger or less than 10. So I'm going to find the vertex here. So I'm going to do my negative b over 2a. In this question, b is 16, so it's going to be negative 16 over 2 times a, which would actually be 2 times negative 16. Don't forget, either put that in parentheses or figure out what that is in that denominator. And if you simplify that, this is only a half. So the t is the time. It's only going to take a half a second for the ball to reach its maximum height. So just want to write also real quick for us. Oh my goodness, that's equal to 0.5. So that might be a little bit easier to plug into your calculator. Alright guys, I apologize. I keep having problems with the glare here on my calculator, so I'm trying to adjust the lighting. Okay, so I went through and I just plugged in. Everywhere I saw a t, I plugged in a 0.5 or a 1/2, so we can simplify this. I'll go ahead and hit equals. So it takes me half a second to reach the maximum height, and as I calculated that, that's 9 feet. So if I'm looking at my graph here, my vertex would be at 0.59. So when it says, is this going to reach a height of 10 feet, then my answer has to be no, because the maximum height it reaches is only 9 feet. Okay, very quickly, this last problem's a little different than the others we've had. It says a farmer plans to make a rectangular garden, so I've kind of gotten that drawn here. One side is going to be against the side of the barn. The farmer has 100 feet of fencing to surround the other 3 sides of the garden. What are the dimensions of the garden with the maximum area? Okay, now in general, area, as you guys know, is length times width or base times height. What I need to do here is try to create a situation where I only have one variable. As this picture is presented right here, to find the area we would do x times y, and then we'd have 2 variables, so I don't want that. So what I'm going to use is the other information they give me in the problem, which is about the 100 feet of fencing. Now, this picture is not drawn to scale, it's just a reference for us. So the opposite sides here, as I have it pictured, this side would be a Y. If I'm working with fencing and I've got this fence next to the side of the barn, let's say that's the side of the barn, I don't need any fencing to go along there because the barn could just provide that side of the fence. So in terms of my perimeter here, I would just have the two sides with the Y, so 2Y plus X, and then I know that they have 100 feet of fencing to work with, so I'm taking that from the problem. And what I'm going to do, I just need to get one of these variables alone. Let me move the mouse there. And it would be very easy to get X by itself by just subtracting that 2Y. So 100 minus 2Y is going to be equal to X. Now, the reason I'm doing this, relabel that side real quick, is because then when I do the area, I can do Y times 100 minus 2Y. That would be the length and the width of that. Okay, now what's going to happen here, I'm going to get 100Y and then minus 2Y squared. This is going to create a quadratic. Okay, let me rewrite it real quick in standard form. So I'm going to put the negative 2Y squared first and then plus 100Y second. That's standard form where your highest power comes first. Now, in terms of this, if you think about the graph here, this is negative, so I know this would turn upside down if I put this on the graph, and I want to maximize the area, so the maximum would just be the vertex. So we're just going to find the vertex here real quick. Now, what it's going to give us, Y would be the side here of the garden, the length of the side, and the A, which would be like where we normally see our Y coordinate of the vertex, that's actually going to be the area. So I'm going to do my negative B over 2A. So for this problem, it'd be a negative 100 divided by 2 times negative 2. So we're going to get negative 100 divided by negative 4. So that would be 25. Now, what this is the side length. The actual area that we want to use is going to be what we get when we plug that in. So I'm going to do negative 2 times 25 squared plus 100 times 25. And I'm going to grab my calculator. All right, hopefully you guys can see that decently. I plugged in the 25 to the equation and I was trying to adjust the lighting there. So I'm going to hit equals. And that area would be 1250, if you can see that okay. So in terms of my answer, this would be square feet since the dimensions are in feet. So ask for the dimensions. So Y is going to be 25, and then X is 100 minus 2 times Y. So X is going to be 50. So in terms of the dimensions, this side 25, this side 50, this side 25, and then the area is going to be that 1250 that we got when we plugged that in.